This time I'm repurposing an old heatsink from NVIDIA FX 5500. I'm going to use it for my dummy load, which is an RF resistor with rating of 100 watts at 50 ohms. So this is just a small dummy load that I will put on a square tube. So this might be capable of handling at least 50 watts for short duration. So let me cut the heatsink and also the tubing for this dummy load. I have now finished cutting the heatsink using the Dremel tool, and next step would be to mount this on the heatsink and solder the SO239 feed point. So I have now finished the connection on the dummy load. As we can see from here, this is directly fed with SO239 connector. So we have the heatsink. I put some heatsink compound on the joint between the case of the dummy load and the heatsink, also with the resistor on the heatsink. So now this is ready for testing. So let's check the SWR of this on the Nano VNA. So this is the finished dummy load that I assembled. So let's check the internal configuration. We have the RF resistor. This is rated at 100 watts. This is the SO239 connector. I connected the center tab directly on the pin of the SO239. The ground tab of RF resistor is connected to the heatsink. This is the heatsink coming from an old video card which I cut and attached to the square boom, aluminum square boom, and secure with a screw. So let's check the SWR response of this dummy load on the VHF frequency, amateur band, and 440 megahertz amateur band. So let's connect the dummy load to my Nano VNA. So let me just focus the camera. So as we can see, we have center frequency is 145, SWR is 1.07, impedance is 49.8 ohms, so almost exactly 50 ohms. So let's check the frequency response of this dummy load on the 70 centimeter band. So let's check. This is calibrated to the 440 megahertz band or 70 centimeter band. We have 440 MHz center frequency. We have 1.2 SWR at 57.5 ohms from 430 to 440. So let's check the impedance on the 430 megahertz band. It's 54.9 or 55 ohms. So at 440, let's use this one to set it to 440. So exactly 440, we have 57 point or 56 or 57 ohms impedance at 1.2. So let's check 435. Let's bring down the cursor at 435. So at exactly 435 megahertz, we have 1.2 still at 70 centimeter band. So this dummy load can actually handle 100 watts on short duration. So let's check this dummy load on my Yaesu 2900. So now let's check the configuration of the radio. We have the Yaesu 2900 and the SX400 SWR meter. So the dummy load is connected at the back of the SWR meter, the power out going to the dummy load, and the radio out is connected with the coax from the output of the Yaesu 2900. So let's check the power output of this radio using the dummy load. So let me focus. So let's calibrate. We are on the calibrate position, and the power is forward power. So let's press the PTT and adjust the calibration needle. So we are on full scale at high power. So let's check the power output. It's low 3. Let's check again. Low 1 is 5 watts, low 2 is 10 watts, low 3 is 30 watts, and high power is about 65 on this radio because I adjusted the power output of this Yaesu 2900. So setting is forward power, calibration is on the middle, and output power is 200 watts. Let's focus on the needle. So let's calibrate. I'm going to press the PTT now. So we have full deflection, release, and go to SWR position. Let's check the SWR response. We have a little deflection, or about 1.1 SWR on this at high power. So let's check the power output by switching the power, function switch to power position. So we are on the 200 watts readout. So let's check. I'm pressing the PTT. We have about 65 watts of power output at 145 megahertz. So our dummy load can actually handle the 65 watts power output of the ISO 2900 without much difficulty for short duration. So if you want to increase the power handling, you need to change the heatsink of the dummy load. So let's check this with the QYT KT8900 for the 440 megahertz band or the 70 centimeter band. So let's check the power output of this QYT KT8900. We still have the same configuration. We have the dummy load connected to the power out of the SX400. The radio output is connected to the input of the SX400. So we have the dummy load. So let's check the power output of this radio using the dummy load. Let me just focus the camera. So let's see if we can make it more clear. Okay, we have frequencies 440, power output is H or high power. So let's put this on the calibrate position and check the needle deflection. We have adjusted to full deflection. So we have full deflection at power output of 20 watts. So we're going to read the power output between the middle line on the SX400. So let's check the SWR. Let's move the function to SWR position. So let's press the PTT. We are transmitting. As we can see, our needle doesn't even move on 30 or about 20 watts power output of the QYT KT8900. This is SWR position. So let's move the switch to power function and the power to forward power. So let's check the power output. We are on 20 watt setting. So as we can see, we have about 16 watts of power output on the 440 megahertz using QYT KT8900. Let's move the power output of the radio to low power. So low. Let's check the low power output. At 440, we have calibrate again. Press PTT and readjust the needle. So we have full deflection on the SX400. Let's move the SWR meter. We still don't have deflection on the needle at low power. Let's check the power output at 20 watts. Still. So we are about 9 watts on low power at 440 megahertz using the ISO 2900 and the dummy load, which can handle 100 watts for short bars. But for low power, it can actually handle the power output of the radio without problem. So that's it. Our homebrew dummy load is perfectly working. Until next time.